All right, thank you for joining me on this question. I'm going to be looking specifically at question 6. So let's have a look at question 6. And it says to use calculus techniques to determine the exact coordinates of any stationary points on the following curves. Use second derivative test to determine whether maximum, minimum horizontal inflection. So let's write the equation. Let's find the stationary points by letting the derivative equal 0 and solve it. So dy dx will be 4 times the bracket to the power of 3 and then multiply by the derivative of the bracket, which is 1. And this is 2x to the power of 0, is 0. So we've got 4x minus 1 cubed to be 0. Therefore, x minus 1 could be 0, so x could equal 1. Now you find the y value when x is 1 by substituting into the equation. So 1 minus 1, 0, 0 plus 2 is 2. So there's a stationary point at 1, 2. Now we test this in the second derivative, and the second derivative will be, there's the first derivative. So the second derivative is, 4 3s are 12, x minus 1 squared. So we put a 1 in there, and we get 12, 1 minus 1, you get 0. Now a 0 indicates a point of inflection. So it's difficult to have a point of inflection because it's a power of 4 can have either 3 stationary points, or a power of 4 could have 1 stationary point, but it can't. You could have 2 point of inflections. Anyway, let's use our derivative test because our question did say, and the sign test if necessary. We're going to use the sign test. So what we're going to do is come up with the x value of 1. Just before 1 is 0.9, just after 1 is 1.1. So we substitute these values into the derivative. We know that when you substitute 1 into the derivative, we get a 0 value, which is a stationary point. Let's see what you get when you substitute 0.9 into the derivative, and it's 0.9 minus 1 cubed. So we get 4 times negative 0.1 cubed. It's negative, therefore we've got a downslope. So we've got a negative value here, we've got a downslope just before that value. Now let's substitute 1.1, which is 1.1 minus 1 cubed. We get 4 times 0.1 cubed. That's a positive value. Therefore, positive value is an upslope. So if it comes down, then it's 0, then it's positive. We call that a minimum at the point 1, 2. So we had to actually use the test because our 0 value was making it think that it's going to be a point of inflection when it's actually a minimum point, minimum stationary point. I hope that's helped. Until next time, stay happy.